Detection of proteins in electrophoresis gels. A protein electrophoresis gel may be stained to reveal all protein bands. Alternatively, specific antibodies may be used to detect specific proteins. B. Western blotting. Here we demonstrate how to use specific antibodies to detect specific proteins. The protocol includes 3 stages. In the first stage, the proteins are transferred from the gel to a PVDF membrane. In the second stage, the PVDF membrane reacts with an antibody solution. In the third stage, the reaction with the antibody conjugated enzyme visualizes the location where the antibody binds to the specific protein. Before disassembling the gel cassette sandwich, have the reagents and equipments ready. A piece of PVDF membrane of the same size as the electrophoresis gel to be transferred, and 8 pieces of 3M filter paper. You may cut the filter paper to a larger size if the samples will be used for sequencing or mass spectrum analysis later. Semi-dry transfer machine, transfer buffer, methanol, a plastic box, a plastic 3-chamber container. Pithy formula: wear gloves, carry paper and membrane by tweezers. Do not let the membrane dry, and absolutely no bubbles. Please wear gloves. Cut the lower left corner of the PVDF membrane. This is to facilitate later orientation. Carefully peel off the protective paper at the upper left corner of the membrane with a pair of tweezers. Use a pencil to write the group ID or experiment number on the membrane. Add 20 ml methanol into the plastic box. Add 100 ml transfer buffer into each chamber of the 3-chamber container. Pick up the membrane between the protective paper by tweezers and put it into methanol. Let the membrane completely immerse for a few seconds and become translucent. Pick up the membrane and put it into one of the transfer buffer chambers to soak for more than 10 minutes. If the membrane floats up, gently press it down with a plastic pipette to ensure complete immersion. Arrange the 8 pieces of 3M filter paper into 2 stacks of 4. Put the 2 stacks into the transfer buffer in another chamber to soak for more than 10 minutes. Carefully push out the 2 spacers from the gel cassette sandwich to create some space at both sides of the gel. Insert 1 spacer into a corner between the plates and use this as leverage to slowly separate and remove the glass plate. If you encounter difficulty, adding a few drops of distilled water or buffer may help. Be careful not to tear the gel. The gel usually stays with the aluminum plate. Rinse it with distilled water to prevent it from sticking too tightly. Decide whether or not to cut the lower gel. Find the boundary line between the upper and lower gel and cut the gel along the line with a spacer or razor blade. Make sure to cut through the gel completely to avoid serrated edge resulted from tearing. Cut off the upper gel. Push the upper gel away and onto a piece of paper towel for disposal. This way, the discarded gel will not stick to other objects. Cut away the lower left corner of the gel as a reference of orientation. Inverse the aluminum plate so that the attached gel faces downward. Use a spacer to peel the gel down to the 3rd transfer buffer chamber. The gel will slide down acceleratedly due to gravity. The gel may absorb water and expand after prolonged soaking. In case the gel folds up after being peeled off, you may use a spacer to unfold it. If the samples will be used for sequencing or mass spectrum analysis, soak the gel for 10 minutes to remove SDS. Otherwise, continue to the stacking step without soaking. Open the lid of the transfer machine and tape the metal plate at the bottom to frame the surface into 4 areas of the same size as the lower gel. Pick up 4 pieces of soaked 3M filter paper by tweezers. Drip off excess transfer buffer and place the filter paper in one of the frames. Carefully place the soaked PVDF membrane on top of the filter paper with the labeled side facing up. Align one corner of the membrane membrane with the filter paper. Slowly lay down the membrane from one side and do not drag the membrane. There must be no bubbles between the membrane and filter paper. Use a plastic pipetter to add some transfer buffer at the center of the membrane. Apply buffer as needed to prevent the membrane from drying. Wet your gloves with the transfer butter. Carefully pick up the gel. Align the cut corner of the gel with the cut corner of the membrane. Also adjust the side of the gel containing large protein molecules as close to the edge of the membrane as possible. Lay down the gel slowly without dragging. There must be no bubbles between the gel and membrane. Try to place the gel successfully at the first attempt. If the process has to repeat, some proteins in the gel may randomly leak to the membrane to produce image overlap or false signals. Finally, stack 4 pieces of soaked 3M filter paper on the top. Cut away the unwanted gel with a spacer and remove the cut-off fragments out of the transfer machine. Gently roll a glass rod over the stack to squeeze out excess water. This step makes the filter paper, membrane, and gel attach tightly and can improve the transfer efficiency. Wipe excess water from the metal plate. Residual water in the machine may cause a short circuit and damage the machine. If multiple gels are transferred simultaneously, add a few drops of transfer buffer at the center of the filter paper on top to avoid overdrive and power shutoff during prolonged transfer. Close the lid, set the current 1 mA per square centimeter based on the total area of the gel and set the time 30 minutes. Start the transfer procedure. When multiple gels are transferred simultaneously, use a capped bottle containing 1 liter of water or a thick book to press down the lid and improve the transfer efficiency. Wash and dry all used equipment and put them back while waiting for the transfer to complete. The machine will show dry warning if the transfer buffer has dried out. If this occurs, open the lid and add a few drops of transfer buffer at the center of the filter paper on top before resume transfer. The voltage usually rises slowly from 5 volts to about 9 volts during the transfer. The safe setting of the machine is 30 volts, exceed which the machine will shut off automatically. The machine beeps at the end of the transfer and stops automatically. Turn off the power supply and open the lid. Flip the filter paper aside with the tweezers. Remove the gel and pick up the PVDF membrane with the tweezers. Determine whether or not the transfer is successful by observing the transfer status of the colored molecular weight markers. If there are still many colored markers remain in the gel, the transfer is not sufficient. After transfer, the gel can still be stained with Comassi Blue G250 to determine the status of protein retention. If you cannot continue immediately to the second stage, rinse the membrane with distilled water, air dry it on a paper towel, seal it in a labeled Ziploc bag, and temporarily store the bag in a 4°C refrigerator. Alternatively, transfer the membrane into a Ziploc bag, immediately add 10 ml blotting solution, seal and label the bag, and temporarily store the bag in a 4°C refrigerator. If the membrane dries during the storage, then you will have to soak it in methanol again before continuing the experiment. If you can continue immediately to the second stage, transfer the membrane into a Ziploc bag, immediately add 10 ml blocking solution, seal and label the bag, and gently shake it for 1 hour at room temperature. Throw away used filter paper and unwanted gels. Empty the water bottle and put the bottle back to its original location. Turn off the power supply, rinse, wipe, and dry the metal plate as instructed to prevent rusting by the residual salts, which can cause poor transfer performance. The liquid waste containing methanol should be disposed to the designated place. Prepare the reagents and have the equipment ready. Washing solution, which usually is PBS plus 0.5% twin 20. Blocking solution, which usually is PBST mixed with skim milk powder or gelatin. primary antibody solution, which usually is the blocking solution mixed with the primary antibody. The working concentration of the primary antibody is about 1 to 100 to 1 to 20,000, depending on the titer of the antibody. Secondary antibody solution, which usually is the blocking solution mixed with the secondary antibody. The working concentration of the secondary antibody is about 1 to 1,000 to 1 to 50,000. Please refer to the user manual. Storage solution, which usually is PBS and is used after the antibody reactions. Protein antibody reaction box. The box needs to be thoroughly cleaned with ethanol before use. Label the box with group ID. Regular plastic box. Note: never let the membrane dry. The solution must maintain a full contact with the membrane during shaking. For PVDF membranes that have been dried and stored after transfer, take the membrane out by a pair of tweezers and put it into a plastic box containing 10 ml methanol. Let the membrane completely wet for a few seconds and turn to translucent evenly. Then transfer the membrane into the protein antibody reaction box containing 10 ml distilled water and wash the membranes 3 times with distilled water. Switch the water with 20 ml blocking solution. Gently shake the box at room temperature for 1 hour and decant the blocking solution. Note: do not save the blocking solution by stacking several membranes together in the solution. For PVDF membranes that have immersed in blocking solution right after the transfer to react for 1 hour or overnight, please take the membrane out of the Ziploc bag by tweezers and place it in the protein antibody reaction box. Rinsing with the washing solution after blocking may reduce the effectiveness of blocking. But if the experiment requests such a step, wash the membrane with 20 ml washing solution by shaking for 10 minutes. And decant the washing solution. Add 10 ml primary antibody solution into the box, put on the lid, and incubate at room temperature with shaking for 1 hour. Remove the primary antibody solution and wash the membrane with 20 ml washing solution 3 times by shaking for 5 to 10 minutes each time. The purpose of washing is to reduce the non-specific binding of the primary antibody, so decant the first round of washing solution as soon as possible. Add 10 ml secondary antibody solution into the box, put on the lid, and incubate at room temperature with shaking for 1 hour. Remove the secondary antibody solution and wash the membrane with 20 ml washing solution twice by shaking for 5 to 10 minutes each time. The purpose of washing is to reduce the non-specific binding of the secondary antibody, so decant the first round washing solution as soon as possible. Finally, add the storage solution PBS, put on the lid, and wash once with shaking for 5 to 10 minutes. Do not pour out the solution after shaking. The membrane may be kept in the solution temporarily and is ready for the detection reaction. Here we demonstrate the Enhanced Chemiluminescence Detection (ECL). Have all the reagents and equipments ready. The ECL kit, which includes the reaction solutions and substrates, calculate the amount of usage for each component before the reaction. Use 0.05 ml solution A and B respectively for each square centimeter of PVDF membrane. Note that the solution A must be kept in the dark. Chemiluminescence imaging system. Please turn it on and set up the software before the experiment. Plastic box for ECL. Thoroughly wash the box with ethanol. Label it with group ID and wrap the box in aluminum foil. Gloves and tweezers. Pithy formula. Wear gloves, use tweezers, follow the order, and watch the time. The reaction starts immediately after the ECL mixed solution is added. Please carry out the experiment in a dark room and beside the imaging system. In the dark room, mix the same volumes of solution A and B, then incubate at room temperature for 3 minutes. Pick up the membrane by tweezers. Slightly drip off the PBS solution. Hold the membrane so that the side with the group ID or number label faces upward and the cut corner is at the lower left. Use a pencil to draw a dot or mark left to the pink molecular weight marker. This mark can help to determine the molecular weight of the target protein later. Open the lid of the ECL box and place the membrane in the box. The reaction solution must cover the entire membrane. Alternatively, use a plastic pipette to take the mixed ECL solution and directly drop on the membrane. Incubate in the dark for 1 minute. Please watch the time. Open the lid after the reaction and quickly pick up the membrane with tweezers. Drip a few drops of ECL reaction solution on the black supporting plate and place the membrane on the plate with the labeled side facing up and the cut corner to the lower left. There must be no bubbles between the membrane and the plate. Wipe clean access reaction solution around the membrane with Kim wipes to avoid interfering with signal detection. Quickly push the plate into the imaging system to take pictures before the reaction signal declines. Refer to your lab instruction to operate the imaging system. The amount of protein transferred, the titer of the antibodies, and the time for operation can all affect the exposure time, which usually ranges between 30 seconds to 300 seconds. Adjust the exposure time according to the actual situation and keep a record. Clean up the dark room after the experiment. Carry away all objects that have been brought in and quickly leave the dark room. Thank you for watching.